Hello, I'm Aaron Gunnarsson with Passive House, Massachusetts, and I'm thrilled to welcome you here to today's Passive House workshop on materials and innovation. This is part one of a two-part series. The second part will be available on Thursday, so same time, same Zoom information. I'll send out some reminders, but you can use the same information and access the session coming up on Thursday as well. But today, thrilled to be here. So as I said, I'm Aaron. I'm with Passive House, Massachusetts. So we are putting on this session today. Hold on, let me actually change some slides here. That's our website there. But I want to do one plug for an event we have coming up in now about 2 months. It's coming quick, but I know November 16th, we're having our annual symposium, and we're returning to in-person, doing it in person in Boston at the BSA space, the same place we were several years ago before COVID. And we're looking forward to seeing as many of you who can make it in person. So please check it out. Early bird registration is open. So if you want that kind of early discounted ticket, you can do that right now. phmass.org gives you all the information for that event. This is also today's session is being sponsored through the MassSave Passive House training program. So I do want to give a quick shout out to MassSave and to their programs before we jump into today's content. I'm sure all of you are aware at this point what MassSave is doing for Passive House, but just in case you're not, I'm going to remind you. So MassSave and the sponsors of MassSave, that's there at the bottom, the various utilities here in the state, have been for the last several years been supporting a Passive House incentive program. And at the beginning of this year, that program was updated to include a single family and 2 to 4 unit buildings. The program works a little bit differently than the Passive House incentive program for multifamilies do, but you can see it listed on your screen. So basically 1 to 4 unit residential buildings can qualify for some pretty good incentives if they achieve a certain level of energy use, which is listed at the very top of those level 1 and level 2 slides, and if they make steps to become an all-electric building, which you can kind of see the requirements listed here. So the idea here is to incentivize all-electric homes as well as low-energy homes. So while Passive House certification isn't required for 1 to 4 unit projects, it definitely does matter to do Passive House steps in order to get down to that energy level that's required. And we hopefully, you can take advantage of some of these all-electric incentives and savings that are out there. The other incentives that are available have been available for the last 3 years or so, now going on 4 years, are for buildings of 5 units or more. So these are the multifamily incentives, but also incredible incentives, great. If you haven't taken advantage of any of these before, I urge you to start with a feasibility study. If you have a 5+ unit building that would qualify, go through the feasibility study program. You can get 100% of the feasibility study covered, regardless of whether or not you pursue Passive House in the end. It's just a great way to sort of get your feet wet and see if Passive House makes sense for the project that you're exploring. So thank you to MassSave for these incentives. We look forward to more and more projects being enrolled. We currently have over 8,000 units enrolled in the multifamily incentive program, which is just an incredible number to see. It's, we're seeing Massachusetts become one of the leaders in the nation in Passive House development. It's because, in a large part, because of these incentives. So thank you for those. Ask questions in the chat room. I'll take care of to answer any about the incentives or anything else that you have related to the MassSave programs and the MassSave training programs. Big thank you to them for putting on these events. So as I mentioned before, I'm Aaron Gunnarsson with Passive House, Massachusetts. Many of you are aware of us, but if you want to find out more about what we do, phmass.org gives you all the info on our upcoming events. Now I want to transition to today's workshop, what we're all here for. This is an exciting event, a 2-day event that's been put together with our friends at Fias on materials and innovation. And like many of our sessions, this came about through a conversation that a few of us were having one day about, well, what new materials are available out there, things like showing your screen right now, wood fiber insulation, all electric water heating systems, and other types of newer materials are becoming available that we see on projects or that we hear about from our supplier and vendor friends. And it led to a question that we had is, well, what systems are actually being used in certified projects? Are these type of materials being used? What other type of materials are being used in certified projects? And to get that addressed, we turned to our friends at Fias, to Al Mitchell and James Ortega, who you can see on your screen right now. And we asked them, and that evolved into this workshop series that they combed through a whole bunch of information that Fias has, in terms of what projects have been certified and what they've used to try to figure out what systems are being used, what materials are being used, and how has that been changing as the various innovations have come about or various other concerns beyond just Passive House certification, things like low embodied carbon and healthier materials. and of course, supply chain issues, all these various things we've been running into the last few years. Has that been influencing what they're seeing in certified projects? Are the materials evolving? Are they changing? Are the assemblies changing? So that's what this session is here to answer. Today's session is going to focus on building envelope systems, and then Thursday's session will move on to mechanical systems, so heating, cooling, ventilation, and hot water. So I'm going to turn things over to Al and James in a second. Throughout the session, ask questions. We want you to be involved. Use the chat room and type any questions there. We can get to them live. We'll also have hopefully a few moments, throughout the presentation where we can actually have you raise your hand and ask some questions directly. We'll see how things go. But for now, use the chat room, and hopefully you can, get your questions answered as well. I'm looking forward to it. So with that said, I'm going to turn things over to James and Al. So take it away, folks. I'm going to turn my screen off, and you can go ahead and share yours.
Sounds good. Thanks, Aaron. Hi, everyone. My name is James Ortega. I am Fias's certification manager for our project certification program, and I'm joined by my colleague Al Mitchell, who's on the certification staff with me. Basically, both of our jobs is to review projects that come through certification for Fias. So pretty much every project that we've certified since 2015 when I joined has gone across my desk at some point. So yeah, welcome everybody. Thank you for the introduction, Aaron. And with that, we got a lot to get through. So I think we'll just go ahead and get started. And then there was already a question in the chat about getting the slides. Aaron, I will make sure you get the PDF of this after the presentation so that you can distribute that to the group. With that, so yeah, we're going to go over some passive building principles to start with. This is the envelope session. So if you've got questions about mechanical systems, domestic hot water, etc., we're going to go over that stuff on Thursday. Today's questions try and focus those towards the building envelope itself. So systems, assemblies, stuff like that related to the actual construction of the building, not necessarily the systems. Of course, those could be good questions too, but we'll go over those on Thursday. So passive building principles. Hopefully a lot of you guys have seen slides similar to this before, but we're looking at high performance insulation, eliminating thermal bridges, getting air tightness included in the buildings, and then including shading and daylighting strategies, as well as appropriate climate specific glazing to try to get these projects to perform really well. Those are the envelope related measures. Enthalpy recovery ventilation or heat recovery ventilation is more of a mechanical system that we'll talk more about on Thursday. So just to give you guys a brief overview. So Fias project stats so far through 2022, over 15 million square feet of projects have been certified certified across the US, which is pretty awesome. Over 12,500 dwelling units have been certified to date. And then the graph on the right is showing, where we've got the concentrations. So over here in the Northeast, doing super well between New York, Massachusetts, Pennsylvania, Connecticut, really booming in the Northeast, which is really exciting to see. A lot of incentives are helping with that, which is really, really good to see as well. Al and I are both calling you guys in from Chicago. Illinois is a little bit lighter of a blue than I want it to be in this graphic, but we're starting to see more projects here in our backyard as well. And then obviously the Pacific Northwest and California are also kind of coming along as well. Washington leading the way in that region. So yeah, today our outline we're going to go through is the different project variations that we see. So this is kind of like what the project types are, where they're located, stuff like that. Common practices is more about the building assembly types we see. So are people going for, vented attics more often, or are they doing compact roofs, double stud walls, et cetera? Those kind of common practices we'll talk about. And then for the enclosure, that's all about what types of materials, systems, and assemblies we're seeing. And we'll try and address like the challenges that we see with the different systems that we've heard from project teams, or that we see even in certification, that, after value engineering happens, in the middle of the project or something like that, what things are we seeing change? And then what the trends are and what we think is driving the changes is something we'll try and talk about kind of per section. So these pieces we have broken out into looking at like specifically at roofs, looking at walls, looking at air barriers, et cetera. And I'll try and address each of these bullet points as we go. Embodied carbon is the new, it's not new. It's been around for a long time. We've been talking about this and know about it, but that's a new thing in our realm that we're seeing more often. And I'll try and speak about the embodied carbon strategies that we're seeing of people trying to reduce that embodied carbon. And then Al's going to talk hopefully about, in words that you guys can understand about good hydrothermal design and what issues and things we see in projects and how we try and mitigate them. And then we'll wrap up with detailing tips about the enclosure stuff. And then we'll hit you guys with some information about cost data at the very end. So that's kind of the general layout of what we're going to try to do. And I already see a couple of questions because of this last slide about New York. So what is New York doing that is them leading the way? Basically, New York's NYSERDA basically had a big impact on that. So New York got on early in terms of training professionals first, and then leading towards incentives for project certification. So they started out with 3 years of giving incentives to professionals in the New York region to get trained and learn how to do better buildings. And then they implemented actual incentives for projects themselves, which is, I mean, that's exactly what you have to do. You have to train people to know what to do first, and then they can start getting projects and getting incentives to actually build them. We've seen a couple of other regions do more of the incentivizing the projects first. And it's kind of a, if you incentivize it, people will come to build them, but everybody's really busy, right? Like everybody right now feels like they're at their wits' ends trying to get stuff, just regular projects done. So the incentives to get professionals trained to start with was a big push in that direction. So I think that's a reason. So back in 2015, 2016, New York was already incentivizing training for professionals in New York. So that's why then projects have kind of taken up faster after that. It's also a very dense market. That's probably the other piece as well. A lot of the projects we see are in New York City, which has a ton of construction going on. And it's just dense area. Okay, with that, I'm going to talk a little bit about the three various the variations we're going to look at for projects. So first, I pulled project data from projects that we've seen in climate zones 4A and 5A. I thought those were the two maybe most relevant to Massachusetts as we have climate change coming and places are starting to warm up. Massachusetts might have kind of the 4A climate zone stuff happening in the next 20 to 30 years. So I thought it would be worthwhile to look at projects in those regions as well. And then building function was the next thing I looked at in terms of, how I'm breaking out this data. So we have data for single family, multifamily, offices, mixed use projects, which are generally we consider mostly residential and then have typically kind of, one or two non-residential spaces on the first floor. So this is a classic like 6-story building, 5-story building that's got a non-residential storefront, like office or something like that on the first level. So those are the mixed use projects. And then school and education projects is kind of related to either literally schools, so like education facilities for actual like teachers with students. And then we also have education in here, which is also like recreation centers is the other piece of that. So this is like community buildings that have an education focus is also included in that group. And then project type. So we're looking at both new construction and retrofit projects in this group. A lot more new construction, which you'll see in a minute of kind of the things I broke down. But these are the general 3 group types. So I'll have data split out based on these different factors, but it's all coming from the same pool of projects that I looked at. And then the projects I looked at were also based on our newest standard and our best standard from the last iteration. So Fias is now in the 3rd iteration of our climate specific building standard. So we're in Fias 2021. So all of the data I have in here is about Fias 2021 projects. And then I've also included Fias plus 2018 source 0 projects, which means that it was the last iteration of the standard from 2018. But it's basically the best of the best because those are all of the projects that also went to net zero as well. So this was to help me focus our line of work at looking what the newest projects are doing and what, according to our last iteration of the standard, the best projects we saw. So it's a little bit more focused. So instead of looking at our entire, all 15 million square feet of projects, this was a little bit more focused for me. I could just look at the new stuff, which I hope will show the trends over the past 3 or 5 years or so. So keep that in mind. It's a much smaller group of projects I'm looking at, not our entire group, because I'm trying to keep up with the times. So based on this, we're looking at about 15 projects in climate zone 4A, and we pulled about 43 or 42 projects from 5A. So that's the two different climate zones we're looking at. So it's a little bit more heavily weighted towards 5A in terms of the projects that we looked at. But that's just a general trend that we see. Colder climates kind of are more concerned about this in terms of passive building strategies than more of the warmer regions. But 4A, we have a good chunk of projects that we're looking at there. In terms of breaking down what the different groups are coming from. So we're looking at 24 single family projects, 21 multifamily, 4 offices, 5 mixed use projects, and then 3 education facilities. So that's the other groups that we're looking at here in this grand scheme of things. And then again, vast majority are new construction. 47 of the projects are new construction, and we've got 6 retrofits that are kind of mixed into this group as well. And the retrofits are, I think there's, we'll see later where those fit in of whether or not they're single family or multifamily and stuff like that. But it's not just one group. I know we have a couple single family, we got a couple offices, stuff like that, that is also retrofit, which is just interesting in general to see what project teams are doing in that regard. So common practices that we're going to look at. So the basic assembly types we're going to be checking out are, so for roof types, we have 3 basic ones. Vented attics, which is really common in a lot of single family and multifamily projects, which you'll see. And then compact roofs, both of the vented variety, which is like a vaulted ceiling where you've got still an air gap above the sheathing and it's vented on the roof pitch. And then compact roofs, which are unvented. So this is either flat roofs or vaulted ceilings that are all, a vast majority of them are vapor closed insulation, so you don't need to vent the roof above it. Wall types we're going to be looking at. The majority of the projects are wood stud with continuous insulation, you'll see, but we also see metal stud with continuous insulation, masonry with continuous insulation, the infamous double stud wall, which are a lot more common in our older group of project sets. So if we had looked at this back in 2015 to 2012, a lot more double studs than we're seeing now, which is kind of an interesting shift. Insulated concrete forms, and then masonry with interior insulation. This only shows up on one project, and it was a retrofit scenario. It's just not a common way to do things. And then floor types we'll be looking at are concrete with continuous insulation below the slab, plywood with continuous insulation below the slab. That was one project that had an interesting embodied carbon strategy to try to reduce their embodied carbon. They eliminated the concrete slab, which scares the crap out of me, but it's an interesting project. And then wood frame floors, those are more above either unconditioned basements or above, crawl spaces, stuff like that. And then just straight concrete, we've seen in a couple applications paired with a frost skirt. Both of those projects were also retrofit, where it was like, you can't get under the slab. You could just dig on the outside because the existing slab wasn't suitable to insulate underneath. So there's a couple projects that are just concrete slab with frost skirt. Both of those, I think, in climate zone 4A. So it's a little bit warmer. Common materials. So sorry, there's a long list, but again, you'll have these slides to refer to later. And this is just basically breaking down all of the window types that we've seen on this entire group of projects. And I'll try and, basically the graphs we'll show later will say how many projects used interstate, how many projects used Schuko, et cetera, stuff like that, based on the different groupings we have. The common insulation types we're seeing. So cellulose is like the king of the roof, basically, like vented attics, stuff like that. Cellulose is the cheapest way to insulate a project. But we're seeing more projects that have mineral wool, mineral board, stuff like that. see the difference between project teams choosing EPS versus XPS. So just for your knowledge, expanded polystyrene, or EPS, is a little bit usually lower global warming potential. It has less embodied carbon in it in the process of making it than extruded polystyrene does, which is XPS. But I've heard anecdotally from a few of our CPHCs recently that XPS has a new formula that they're coming out with to create that product, which is much closer, much more on par with EPS. So it'll be interesting to see how that evolves as more manufacturers start to look at embodied carbon in their products themselves and try and reduce that in their manufacturing process. And then air barriers, all of the different varieties we will see on these project types, but fluid applied air barriers, membranes, self-adhered membranes, which is slightly different because they've got, it's sticky stuff on the back versus the other one, which you have to tack into place. Smart membranes we'll see on a couple projects were used as combination of vapor and air retarder. So we'll see kind of which projects that worked on. Tape gypsum. This was a fascinating one for me. It was just on one project. I think it was actually located in Chicago, where we've got pretty strict fire codes. So they needed to have double gypsum as their exterior sheathing, and they used that as the air barrier. So that was kind of interesting. Taped OSB, super common. Taped plywood, very common. And then zip system, which is basically a proprietary taped plywood or taped OSB system, pretty much is what zip is. And we see a lot of project teams actually specify that in the drawings. So if it didn't say zip sheathing on the drawing set, I didn't include it in that group, and I called it either taped plywood or taped OSB, depending on what the sheathing type was. So these are the common materials, common stuff we're going to be looking at in here. And then this one is a plug just for your guys' information, because it comes up a lot on projects that have glazed doors. So this is just our top list of glazed doors we've seen on projects that have worked in climate zones 4A and 5A over the past 5 or so years. So I'm just listing the door manufacturers right here and then the specific products we've seen. The hardest part on most glazed doors, and we typically see these in multifamily buildings that obviously you need to have an entrance that's ADA and egress accessible, stuff like that. So these doors it's tough to find really good thermally broken doors that have the threshold required for ADA access. And these are some of the doors we've seen on projects that were approved for the project, and we're passing both our condensation, comfort, and just the overall U values were pretty decent for these doors. So these are all the ones we've seen. I'm sure there are more, so I don't want to be plugging specific manufacturers, but these are the ones that we've seen used on projects over the past couple of years. So we wanted to highlight this one specifically because we constantly have project teams asking us okay, what are you guys seeing? It's really hard for people to find stuff, especially with the current the current market. It's really difficult to find products that are meeting these really tight U value requirements, and more specifically the condensation risk issues that happen, especially at the door sills when they're just you got metal bridging straight to the inside of your building. It's kind of tough to fix that. So these are some of the thermally broken doors we've seen. Okay, so jumping into air barrier types by climate zone. So in 4A, again, remember the project distribution don't worry about that too much in terms of the climate zones. A lot fewer projects were in climate zone 4A. There are a lot more in climate zone 5A. A lot of projects, though, use the zip sheathing system and actually specified in their drawings. So that's a big one. It's basically the green exterior of an OSB panel and then taping the seams. Really, really common in 5A. And basically between taped plywood, taped OSB, and the zip sheathing system, that makes up 80% of the air barriers we see in both of these climate zones. So this is pretty interesting. And then, kind of far behind are the membranes. Tape gypsum, again, was only one location that did that. And the smart adhered and self-adhered membranes are both kind of low on the totem pole. It's much more common to see hard surfaces that are actually taped and reliable. And we've seen this in practice as well, that this is a situation where, okay, you can have a 10 millimeter thick membrane, what happens if somebody hits it with a hammer, right? Like it's not a very reliable membrane when you're actually constructing it in the field, which is why we see a lot more solid air barrier planes in both of these climate zones pretty consistently. Based on the project distribution type, I thought this was really interesting. So single family, multifamily, again, that same trend is true where it's taped OSB, taped plywood, or a zip system for the air barrier functionality. But the one outlier, so for the school and education facilities, all of those projects used fluid applied membranes or fluid applied air barriers, which I don't know why. I mean, it's not a huge sample. It's only 3 projects, but all 3 of them by different architects, different CPHCs used the, fluid applied membrane, was pretty interesting to me at least. But in general, the trend for office is a little bit the same as the single family and multifamily. A lot of them use this kind of solid system for taped OSB, plywood, or zip sheathing. And then for the mixed use, it's a kind of a mixed bag there a little bit. Self-adhered membranes are a little bit more prevalent, but it's 2-to-1 on those few projects that in the mixed use section. Now, new construction versus retrofit is a little bit more varied on retrofit, which makes sense, right? All of these conditions, all of these wall assemblies are going to be different. It's just trying to do the best thing you can for that particular building. And then one other thing I'll note is that on all of these air barriers, I chose to record what the main strategy was. On a lot of retrofits, they have to do many strategies, right? Like because they're just trying to fill in around different wall conditions, etc. So I just chose the main one that was used for the majority of the structure when recording in here. But new construction, again, vast majority taped OSB, taped plywood, zip sheathing. Now looking at roof types by climate zone. So again, vented attics are in the blue. Compact but vented is in the red, and then compact and unvented is in the yellow. So based on climate zone, attic vented and compact unvented are the 2 most common types in both climate zones. We don't see a ton of vaulted roofs that are unvented, vaulted roofs that are vented in either of these climate zones. And I would say the majority of the compact unvented assemblies are flat roofs, so built up flat roofs. Insulation types then by the climate zones is the next thing I'll chime in on here, just because these are kind of related to each other. So again, because we saw a lot of projects with the vented attic, cellulose is really prevalent in both 4A and 5A. And then because we also saw a lot of projects that had an unvented but compact assembly, polyisocyanurate is the other really common roofing material that we see in a lot of these projects. Depending on how cold the location is on the compact roofs that are flat roofs, a lot of times we'll just see it with the built-up insulation on the exterior. So just layers of polyiso tapered for the drainage plane. But if it's really cold and they're trying to reduce how much exterior insulation they have, we will see some project teams that fill the truss or the cavity below that with cellulose or fiberglass or something like that as well. So that's kind of an interesting thing to debate on what you're going to do. And we'll talk about this later when Al talks about hydrothermal stuff, but that ratio between how much insulation you're doing above the roof and how much insulation is in the cavity is really important, and something Al will touch on later. So then roof types by building function, single family and multifamily, again, a lot of projects doing attic with the vented attic. More projects basically in the multifamily doing compact unvented. So again, a lot of flat roofs built up. And single family was the only one that has the compact vented roofs in it. So that's a vaulted ceiling with venting above the sheathing. Schools and mixed use, all of those were compact or unvented. So again, flat roofs on both of those types of projects. And then only one office had the vented attic. All the other ones were compact flat roof. And again, insulation types kind of mirrors what's going on with the roof types chosen. So cellulose, again, kind of king among the insulation types for both single family and multifamily, and then polyiso close behind for the flat roof scenarios. Roof types by project type. So for the new construction stuff, kind of mirrors the other two. Vented attics, pretty common, and unvented compact roofs, also very common for new construction. Retrofit was a little bit more on the compact unvented side than the others. And again, this was because it's existing roofs. If the existing roof was a vaulted ceiling or something like that, and you're really trying to beef up that R value, pretty much the only way those projects could, majority of them do it, was with closed cell spray foam in between the rafters. So they removed the vented strategy, they made the roof a compact unvented roof, and then just beefed up the R value as much as they could on most of those retrofit projects. Most retrofit project teams, especially the ones we see, are using low global warming potential closed cell spray foam, like Demolac, I think, is one of the ones that I see pretty commonly. But so they're doing their best, and they're just trying to use the materials that are available to them to get these retrofits completed and performing well. Let's see. Yep. So again, roof insulation types by project type. A lot of cellulose and retrofits, a lot of polyiso and retrofits, but again, cellulose is kind of the most common we see on all of these, whether it's new construction or retrofit. Okay, looking at wall types. What brand is low carbon footprint spray foam? Yeah, there's a few out there. Demolac, I think is what it's called. Or Al, can you maybe search and do a couple searches in there? Let's see. Oh yeah, closed cell spray foam wasn't on the list. It definitely is. It might just not have. I might have to update this. I'll update this before I send Aaron his slides. I think there is closed cell spray foam on the list. It just didn't come into my slide here. Let's see. Yeah, Al, if you can throw that in the chat, that'd be great. Okay, wall types by climate zone. So again, wood studs with continuous insulation is the most common wall type we see on most of these newer projects. Second, next in that order would be double stud walls. So we still do see quite a few double stud walls, but not nearly as many as we did. Again, like I said, maybe 10 years ago. And then, metal stud is sprinkled in there, masonry with continuous insulation, etc. Let's see. Wall insulation types by climate zone. So now going back to insulation, cellulose, again, pretty cheap way to insulate a building. So we see that a lot on most projects. We're also seeing polyiso used a lot on wall assemblies. And I think this is kind of related to the Zip-R sheathing system, which includes both the sheathing and the polyisocyanurate insulation, kind of a packaged thing that you can purchase. So we see that used quite a lot, especially on multifamily projects with Zip-R sheathing. Fiberglass is still pretty highly used as well as kind of either cellulose or fiberglass for the cavity insulation. And we're seeing not as many as I think I would like, but we're seeing a couple projects with wood fiberboard as the exterior insulation. The one thing I think that's kind of discouraging the use of wood fiberboard on these projects is that it doesn't have that great of an R value per inch. So if you're trying to use it as continuous exterior insulation, you kind of have to lather it on there pretty thick if you want to get the R value that you need on the exterior to meet the hydrothermal ratios that Al will talk about later. So we're not seeing it quite as much, but we've seen it on a few projects. Wall types by building function. So again, single and multifamily, the vast majority are using wood studs with continuous exterior insulation. No double studs at all on multifamily projects or school and education buildings, but we are seeing them a little bit on single family, one office and one mixed use project, which are both relatively small, the two that use the double stud walls on those two projects. And yeah, I mean, that kind of sums it up. Wood studs with continuous insulation is kind of the most common that we're seeing for the most part. And then by building function for insulation types again, so single family, a lot of cellulose is being used, and then kind of equal between EPS, fiberboard, EPS, fiberglass, and mineral wool. The same 5 projects basically use those combination of materials. Multifamily is a little bit more varied. So a ton of projects use polyiso and multifamily, again, because of the zip bar sheathing for the most part. And then a lot more multifamily use fiberglass than used cellulose, which I thought was kind of interesting as well for the cavity fill. The rest are kind of, offices, a lot of more use cellulose, and then mineral board was used more often on mixed use. And I think that kind of stems back to trying to be more fire resistant for those mixed use projects. And then new construction versus retrofit. Again, new construction, a ton of wood stud with continuous insulation. Retrofit, kind of 4 of them were using wood stud with continuous. The rest of them are more varied, with one masonry project with interior insulation that, it's an existing masonry building. They didn't have space on the exterior to insulate, so they had to insulate to the interior, stuff like that. Again, cellulose, fiberglass, and polyiso are kind of the top 3 wall insulation types used on most of these projects, with mineral wool being kind of the next one in line there. Okay, looking at floor types. So this one's a little interesting, just because floor types are, again, whether it's a slab on grade or an unheated basement or something that below will kind of lead the way for floor types. A lot of the projects we look at were slab on grade or a heated basement where it's, direct contact with the ground for the floor assembly, which is why concrete with continuous insulation is the most common in all of these scenarios. So, kind of regardless of climate, most of them use concrete with continuous insulation below it. So the most common insulation types we're seeing right now are expanded polystyrene. So again, kind of the lower global warming potential. But XPS is more common in the colder climate because it has a slightly higher R value per inch. So that's, I think, the reason we're seeing it more in climate zone 5A is because XPS, they're trying to get that extra R value below the slab is, I guess, what we're seeing. There's a quick question in the chat. Does Fias evaluate proposed materials based on life cycle durability? Fiberboard is a red flag, and I would argue our OSB is also. So right now, we don't really have any kind of recommendations or any kind of research done into life cycle durability. We mostly leave that up to the project teams to determine what they would choose for their materials. And again, yeah, like foam is used a lot, especially in continuous insulation. I think for both the price point, insulation value, and I would probably argue life cycle durability is pretty good on foam as well, unless it's exposed to, UV radiation. It's going to stay there for a really long time. Floor types by building function. So again, single family, multifamily. This one was pretty interesting. Only concrete with continuous insulation in multifamily, which makes sense. You got to have a good structural foundation for your multifamily buildings when you're going three or more stories, stuff like that. So only concrete with continuous insulation on those ones. The concrete one is one of those school education facilities. There's 2 of them actually that were in that group that were both retrofit. So they couldn't do anything about the sub-slab insulation on the concrete. They couldn't do anything by putting insulation on top of it. So it's just concrete. And then they installed a pretty significant frost skirt around the exterior of the building on both of those projects. The couple that are plywood, well, the one project that's plywood with continuous insulation is actually a slab on grade, which is kind of interesting. They just did 2 layers of plywood, their vapor retarder, and then the continuous insulation below it. And then the couple of wood framed projects are both projects that had either an unheated basement or were above an unconditioned suspended floor type of situation. So again, EPS and XPS are the most commonly used materials for below, for floor insulation. There's a few projects in the office category that use mineral wool as their continuous insulation below the slab. And it's not mineral wool. Actually, in this case, it's sorry. 2 offices use mineral wool, which were kind of above a suspended floor again. And then mineral board is actually used in a couple of applications below grade, which we don't see a ton of, but we've seen on a couple projects where it was actually used as below the subslab insulation in direct contact with the ground. There's only a couple manufacturers, I think, that use mineral board in contact with the ground. Most of them don't. So I would definitely check with your manufacturer before you do that. Not that common, but I thought it was an interesting tidbit that we've seen a couple project teams do. Let's see, floor types by project type here. So again, new construction, almost all of them are concrete with continuous insulation. I think the plywood plus continuous insulation was also in the new construction group. I think I need to update this or something because it's not showing up. Again, just the one project was new construction that did that strategy. And then the, retrofits, concrete, kind of whatever you can do with a retrofit, basically. And this one again, EPS, XPS, the most common insulation types, regardless if it's mostly if it's new construction. On the retrofit side, it's whatever project teams can make work in their situation. Window types, sorry, this is kind of tricky because there's so many window types that we saw used on all these different projects. And again, because I'm looking at climate zone, I'm not looking by state. There's a vast number of window types used because regionality is a huge factor in what windows are available in which area. So that's why there's so many listed. I think if I just looked at like just the Northeast, this would probably narrow the list down a little bit. Or if I just looked at the Pacific Northwest or something like that, it would probably be a little bit different scheme here. So if there are window types that you've never heard of and you've been in the business in your area for a while, it's probably because they're not that common or they're not really available in your region. So, just have that caveat when you're looking at this list. I simply didn't want to leave any options out because we do see a lot of good window manufacturers out there that are used pretty consistently. So in the colder climates, the most common window types we see are Alpin and Intis. With kind of right behind that is Clearwall is kind of the next group of window types in the colder climates in 5A. In the mixed climate, so in 4A, I'd heard of this brand, but I didn't know it was used that often until I did the study. But we actually had 4 projects that used Interstate as the window manufacturer, and then the next one in that list was Zola Windows, which, sorry, it's a little bit light here, but that's that light blue bar on the far right is the Zola Windows. So those are the 2 most common used in climate zone 4A. And then by building function, it varies pretty significantly. So in single family, the most common we saw was Alpin, followed by a manufacturer called Maverick. And then actually tied with Maverick is Zola, also on the single family side. So Alpin, Maverick, and Zola were like kind of the top 3 we saw used on the single family projects. Multifamily, Intis was the clearly ahead used manufacturer, followed by Alpin and Interstate. Offices was kind of tied across the board, and then mixed use, slightly more project, 1 versus 2 projects, or 2 projects versus 1 used Alpin over the other manufacturers. And school and education, it's kind of an even split between those 3 manufacturers, which I believe is Alpin, Alpin, Conair, and Wasco. Windows was the last one used for the school and education projects. So new construction versus retrofit, again, Alpin and Intis, and then Zola are kind of the top 3. Retrofit, Alpin was the most used, but again, it's 2 versus 1 from the other manufacturers, and the other manufacturers used were Conair, Schuco, Sierra Pacific, and Wythe Windows for the retrofit projects. All right, Al, I'm going to turn it over to you now for some hydro conversation. Unless we have more questions that anybody had about materials, maybe this is a good stopping point for like window questions or anything else like that.
Yeah, we have no further questions in the chat room, but if folks want to use the raise hand feature, you can ask a question directly. James, I'll actually start. There's a lot of surprises here for me, actually. One of them, going back to where you were talking about the wall, air barrier types, you were showing how popular zip system and other types of taped, sheathing systems are. Lately, anecdotally, I've been seeing a lot more, it seems like a lot more membrane systems being used. Have you noticed this breakdown that you're showing now? Have you noticed this been changing, or has this been staying pretty consistent?
Yeah, it's a good question. So I think it's been fairly consistent from our point of view. And again, these are all projects that have either been design certified or fully certified that I looked at in this group as well. I don't think I mentioned that at the beginning. But so most of these have already finished the design process, are now either in construction or have been fully constructed. We might be seeing a few more membranes used in actual, like, through the certification process, but I don't want to make a big judgment on that until we actually see them get as far as getting, priced out and then hopefully built. These are the ones that obviously it worked well enough, especially for the fully certified projects, to meet our air tightness requirements. So I don't know, Al, maybe you can chime in here too. I don't know if we've seen a ton of membranes used on for air tightness. At least we've seen plenty of vapor retarders used for membranes, and obviously water resistant barriers. We see a lot of membranes too, but air barriers, I don't know. Al, what do you think?
It's not as common as the integrated product like zip or just taped plywood or OSB, but we have seen some of it applied on top of another board as a primary air barrier, and a lot of that's the peel and stick roll on, and that usually comes as well in a concern where people are looking for something where they're trying to find a really vapor open air barrier or WRB type situation so that they can get away with a double stud. And that would be like Mento 1000 or like the Henry Blueskin 100 VP product, where it's a peel and stick type thing. But definitely on the single family side, not as much on a larger multifamily.
Yeah, go ahead, Hank.
Yeah, thanks. I've continually been interested in the question of the zip system and how permeable it is. Do we count it as a system that's breathing to the outside? I've heard many different arguments that say that the OSB base of zip is permeable if it's wet, which I don't quite gather the import of, and that the green coating is in fact permeable. But I just have reservations about whether this is really a permeable material. If we have to claim that, we have to somehow wet the OSB. Have you dealt with that question?
Yeah, we see that one a lot frequently on hydrothermal concerns and double stud assemblies. And I believe Zip advertises their permeance for their product as 12 perms, which would be fairly vapor open. But I think they're just referring to the gooped on fluid applied membrane essentially on there. OSB plywood, a lot of the wood products function very much like Intello or a smart membrane, where their permeance changes based on the relative humidity and the moisture content of the material itself. And so OSB, it is true, like OSB's permeance increases as the relative humidity in the material itself increases. Where this becomes a concern is how wet does that environment it needs to be in need to be to make it permeable enough to allow an assembly to dry to the outside.
Right.
And
how wet is wet?
Yeah, exactly. And that's where it ends up coming into where we end up running those analyses in Woofy, just to try and make sure that we're not going to have things to have that condensation there. And usually because most wood products are around like 12% moisture content, we don't see rot develop in them until a consistent period of about 20% moisture content or higher. And that's that rot on the inside of the OSB is the frequent mode of failure of those assemblies where they are having hydrothermal issues.
Yeah, so it's a cautionary note.
Yes.
Thank you.
Which I think there's a question in the chat. Can we comment on the impact of manufacturer marketing efforts versus best performance products? And I think that is like Hank said, like people tell us we're advised that certain products are sort of a silver bullet, or that this will solve all of your hydrothermal concerns, or you really need a smart membrane because it's going to solve it. But I'm not sure that's the case. I think good design and good detailing first can mitigate your risk there. And then if you need to grab onto a specialty product, it might be worthwhile, but you really need to do more analysis and thought on it to make sure you're making that decision correctly.
Yeah, and I'll comment on that as well. In terms of, like in terms of insulation, I don't think we see a ton of like performance versus manufacturer marketing issues, not as much anyways. It's kind of whatever's available in the region, what the architect was already used to working with pretty much is fine for most insulation types we see. But in terms of windows, I think it definitely does come down to marketing and what performance looks like. And more even so than marketing is, a lot of project teams, a lot of people will do, I'll try any window manufacturer once, but if they don't deliver or like they have issues, and a lot of times it comes down to like lead times in terms of like what types of products are used, especially for windows, especially right now. So that I think comes down to it a little bit more than actually like how good is the product itself. It's more along the lines of, okay, could we get it when we needed to, that kind of idea. So that I think is pretty prevalent on Windows specifically. There are a couple more questions in the chat. So, okay, can you please also cover sliding glass doors in the same detail that you did for Windows?
We just don't see a lot of sliding glass doors.
Yeah, lift and slide we see plenty of, but primarily in single family projects. I've seen very few projects that had lift and slide doors in multifamily building, just because those suckers are heavy. I mean, like it's already scary in a single family home. I can't imagine just like, 80, 100 plus random people moving into a new building and you get stuck with a door that weighs like 150 pounds or something like that. Like, it's just like I don't know. It seems like a disaster of broken fingers waiting to happen. We could, though. I mean, we could dive into the single family projects and do another retake and see which ones had, these lift and slide doors. But I think I could sum up on like, there's probably 3 or 4 manufacturers that make good lift and slide doors that we see on projects. And then there's another question about Paradigm. I thought they were used frequently in Massachusetts. I'm assuming that's a window manufacturer. But I have not heard of them, and they weren't on this list of projects that I went through, so I'm not sure. So sorry about that one. I'll do a little bit more research, but it wasn't on my list of these, however many projects I looked through on this one. Let's see. Oh yeah, and then Michael had I don't use products that are going to self-compost. Yeah, that's probably a good rule of thumb.
Good rule.
Yeah. Go ahead, Hank.
Yeah, I wanted a quick follow-up on your breakdown on insulation types. You noted fiberglass as being used a fair amount, and I wanted just to clarify: is that dense pack loose fiberglass versus batt, or is that actually batt insulation?
Oh, that's a great question. I did not make this distinction when I went through. But my guess would be it's mostly the blown in, like dense pack fiberglass. We see batts occasionally used, but more often for like sound attenuation than actual like R value in the walls. And typically not in these 2 climate zones. We might see it more commonly in a warmer climate zone, I think. But from an installation perspective, I feel like bad insulation, it should be easy, but people make it really hard and it's just not as good.
Right.
Yep. Okay. And then there's a couple questions. What are we referring to when we say concrete floor with EPS? Is that a slab on grade or a basement or a crawl space floor? So that if it's concrete with EPS, that is typically a slab on grade or a heated basement, where it's in direct contact with the ground. Typically not a crawl space floor. We don't see a ton of crawl spaces that are made of concrete, where the floor between the interior space and the crawl space is concrete. Not usually concrete. Usually that's a framed assembly kind of between the crawl space. And then, yeah, sliding windows and doors do not perform well because the gaskets fail due to abrasion, for sure. Yeah, we see most of these windows that we've looked at are either tilt and turn windows, awning, hopper, or fixed windows. Those are kind of, or casements in there too. But very rarely do we see either double hung or even single hung windows on most of these projects.
I have a quick follow-up question on that. Has anybody done, 2, 3, 5 years later, blower door tests on buildings where double hungs are used to see if there's really what we expect? We expect that the infiltration is gone way up because of the operation of double hungs, but I'm wondering whether anybody has actually done before and after testing of that. Love to see it.
Oh, I would too. I don't know if we haven't seen that level of before and after where they checked it right when it got installed and then checked it later. We have seen retrofit projects that had existing double hungs and they wanted to get a baseline for the air tightness. So they took a measurement then. A lot of those projects, it's really tough to pressurize it because they're super leaky. And again, because it's a retrofit, I don't know how much can be attributed to leakage through the windows versus leakage through the regular wall and roof assemblies and stuff like that. But we've seen it on a couple retrofits where they tried to get a baseline and then did the deep energy retrofit and made it passive and then tested it. And then they made our requirements. But no, I'd be curious too. I don't know. I don't have any data on that though. It'd be an interesting study for sure. Okay. We might have slaked questions for a second. I'll scroll back down and I'll hand it over to Al to talk about hydro, which is good. It's kind of related to one of Hank's earlier questions too. So go for it, Al. I'll mute for now and I'll just I'll steer the screen. How about that?
So yeah, as has been mentioned and alluded to in some comments here, is there are concerns about hydrothermal performance of walls. And for people on the call not familiar with the term hydrothermal, hydro is dealing with water, thermal is dealing with heat, and you put them together. So it's about the moisture, typically in the term of vapor drive and heat flow through a building assembly where we get concerned. So it wasn't as big of a concern until the buildings got much more airtight and much more insulated. And at that point in time is where we see the drive for hydrothermal analysis to become more important. And that's because the walls and the roof have less of an ability to dry out based on warm air flowing through them. So we tried our best to simplify this as much as possible. And in our guidebook, we have an appendix B, which is all of the prescriptive paths. So it tries to help you identify a wall type or a roof type and then see the requirements that are related for that. If there's not a prescriptive path for something, then for certification purposes, we require a hydrothermal analysis. So on the next slide, I've gone ahead and pulled out one of the sections on walls. Then, as James identified earlier, we typically see a lot of framed wall assemblies with some kind of outboard continuous rigid insulation. So highlighting that from the guidebook here, we use a sheathing to wall, a sheathing to cavity ratio, and that's a 1D analysis. So if you've got 2 inches of R5 per inch foam on the outside, that's R10. And if I've got 5 inches of R5 per inch cellulose on the inside. It's ridiculously good cellulose. We'd also have R25 in there, so we'd have 10 over 25 to figure out our sheathing to cavity ratio of 0.4, and that would be okay for climate zone 5. So these ratios here are just meant to be simple and easy to follow in that regard. And obviously and as noted in the slide here, the colder climates require more sheathing insulation than the warmer climates would. And that's about that temperature gradient through the wall, where we're trying to keep preventing a condensation plane on the inside of that outer insulation. On the next, we got a question, how do I make the left text larger? We can go ahead and do that live here. This is also, as I mentioned, in the Fias guidebook under Appendix B. So I can drop we'll show how to get to there. So if you go to the Fias website, under resources, there's
as my computer takes off like a jet. Yeah. Yeah, my internet's slow, but we'll put a link in the chat.
Yeah,
later.
we'll put a link in the chat, but this is for free and publicly available in that Fias guidebook. On the next slide, I've got a graph that I pulled from that from Woofy Pro, which is our 1D hydrothermal analysis software we use. And we'll go ahead and make that a little bit bigger too. And on the top graph, I'm showing the temperature gradient through the wall in red versus the dew point in purple. And you can see the slope of the red line changes. It's steeper through the foam insulation on the outside, which is more ARB per inch, while it's a little shallower of a line through the cellulose on the inside there. And that concern point is typically on the inner. So this is an assembly that's got foam on the outside, like a zip sheathing product, zip type sheathing product in the middle, and then dense pack or fiberglass on the inside there into a 2x6 stud wall. And one of the things we're looking for here is we want that temperature gradient line to not cross with the dew point line, because when the temperature drops below the dew point, you've got condensation. And that's also identifiable by the green line on the bottom graph. So, excuse me. In that point, we see a point of greater than 80% relative humidity, and that would typically be one of the concern points there in terms of, is there a chance for condensation to happen, to get further testing on that area. This wall would follow the prescriptive ratio, because this is that the 2 inches of foam over the 2x6. So it's validated already per our prescriptive path, our prescriptive options there. But I just wanted to show the detail of what's actually happening inside that wall assembly on a cold day. On the next slide, double studs are sort of the hydrothermal hobby horse and contentious item that we all love to discuss. And our guidebook typically recommends it, or does not recommend it above climate zone 3. And that's based on, as we were discussing earlier, that primary mode of failure being the rot on that inside of the outer sheathing. So through trying to solve problems on projects and also the best available resources, there's typically 2 paths that might work if you want to use a double stud. And I fully understand wanting to use a double stud for simplicity of construction, especially the embodied carbon, where people are concerned about using a plastic insulation when you could use all cellulose or something like that. So one of the options, and that's what's shown in this graphic here, is we call it the BSC wall, and this is based on the work of Joe Steebrook and John Straub, and that's putting a interstitial an interstitial OSB or plywood air barrier layer in the middle. It protects that air barrier layer from damage while mounting things on the outside, and creates vapor drive across the assembly. So this is essentially working very similar to a Larson truss would, and prevents that typical buildup of moisture we see on the inside of that outer face. The other option that we've seen work well is an extremely open vapor sheathing, and this would require hydrothermal modeling to confirm. But there's a product that has been used with great success, which is Georgia Pacific's dense element barrier system, and it's a gypsum and fiberglass based sheathing board product that is more resistant to moisture, but also incredibly vapor permeable to work as a WRB. Yes, I see Mark's comment in here about the double stud walls and up there that didn't read Mofi, and that is that is a criticism we've received, and we've reflected on it as well. And and the reason why the Wolfie modeling seems to be inherently conservative is because it is inherently conservative, and we're trying to prevent any chance of failure in the assembly after it's built. Let's see, Hank's got a question here, or his hand raised.
Yeah, I have a comment.
Yeah.
The house, my passive house is built with a double stud wall. And as per the last portion of this slide, I was totally devoted to the idea that I was going to have an extremely vapor open breathing to both sides. And I used Den's glass on the exterior sheathing.
Mm-hmm.
And I found that the one of the really nice qualities of the double stud wall was that I could then use X strapping on the inside of the outside stud to get the shear I needed, which can't get out of the Den's glass. That's the downside, is the Den's glass doesn't give you the shear capacity of the plywood, but you can create that with X bracing on the inside of your outside stud. And I've been monitoring the moisture in my walls, and so far so good.
Very cool. Yeah. I think I do think, yeah, dense glass and dense element are both Georgia Pacific products that are very similar in nature. I think one of them is an integral WRB, while the other one you have to apply your own. And I think and dense element I know is the one with a WRB built in. Oh, thank you for sharing the thing. So yeah, that's a common solution that we've seen people consider while looking at this. I do think I'd love to do more long-term monitoring and testing and to really validate this as much as possible. It's just time and money as always. Moving on to the next slide, I've identified, this is an hourly plot of the water content, moisture content in that interface of the OSB. And our current rule is 20% moisture content is when it becomes a rot risk. So I've identified that peak on the graph here. And then the other one too, that is sort of one of those, goes back to things that are advertised and are they actually as they're advertised, is the Cdx plywood. And some people say it's much more vapor open, and it's advertised as a much more vapor open product. But again, it's based on that relative humidity around that material that drives its vapor permeance. So in order to get Cdx plywood to work effectively as the mythical vapor open sheathing layer, you'd have to have a high enough moisture content in that material to cause the material itself to rot, is what I've been seeing. On the next slide, we'll talk quickly about floors. So this is something that we've been trying to clarify and revise. There's a risk of a bulk water event over some floors where you might have either, and we're talking about wet rooms, so like a bathroom or a kitchen or a room with a water heater in it, where if one of those were to fail, it might saturate all of the insulation materials in the floor. And that's why we've created a prescriptive requirement to limit the amount of air permeable insulation, so cellulose or fiberglass, to 2.5 inches in that assembly, in spaces that are subject to bulk water risk, and to require a waterproof membrane. If an overhanging floor doesn't have a risk of a bulk water event in it, you can get away with just following the same hydrothermal requirements for exterior walls. On the next slide, we'll talk about roofs, and I've got that same excerpt here. For roofs, it's typically not the sheathing to cavity ratio as much as it's the percentage of air impermeable insulation on the outside to the entire insulative value of the assembly. And this is fine whether you've got the compact roof assembly we've discussed earlier, where you've got a rigid foam on the outside and maybe there's some kind of cellulose or fiberglass packed in between the studs or the joists. Or we've also seen success with like a flash and fill strategy in this regard. You could always go vented on top of an air permeable insulation as well. So again, these are just the quick prescriptive simple guidelines for roofs. On the next slide, we should have a little bit about condensation risk. So some details in thermal bridging may need to be tested for condensation risk. And it's fairly rare that joints, like as demonstrated here between the wall and the floor, tend to be a condensation risk. But that spot there where it is 18 identified in this graphic is like 18 degrees C is where that could happen. So we have a calculator and a protocol set up to use Therm and Excel to do an ISO 13788 condensation risk test. And then the other thing we'll typically identify as well as any type of point thermal bridges, especially where things are bolted into the building, like a canopy is attached or a deck's attached to the building. There may be a need to use spray foam insulation on those bolts that penetrate the building envelope. Yes, and Mark talking about the with the bearing do you see that, Mark? Is that a lot in where like joists penetrate that masonry wall where you're seeing those concerns, or is it more inside the wall assembly itself, just based on how you do the insulation? Yeah, joists are a decay risk. Yeah. So, and that where you've got structure that you've already got to deal with, that's where it becomes incredibly important to make sure you're not going to have condensation around that. And it's there are drywall over cold masonries and mold risk. Yes, I would agree with that as well. So speaking of detailing, on the next slide, we've pulled out a couple tips that we have and we give everyone, and these are images from our sample project we have on the website, and that's to print out your drawings and do a traditional trace your control layers test. And if you have to pick up your pen, then there's a gap in the control layer that needs to be rectified in the detailing. So here we've got the control layers identified in this graphic and then traced out on there. We've got the vapor control layer on the inside of this assembly. We've got the water control and the thermal control layer on the outside. On the next slide, I've got another detail from this same project where those control layers have been carried continuously throughout the foundation detail. So it's not just in the wall, but at the joints between the wall and the floor, the roof and the wall, especially when you're concerned about moisture or condensation risk. So I think that's all of the, do I have one more on here, James? Nope. So that's all of the hydrothermal and detailing content we have. So I'd be happy to field questions or discussion on any of that at this time.
Yeah, so Al, you mentioned potential bulk water intrusion conditions, and the recommendations on these should consider limiting the potential for the occurrence of mold, so no absorptive materials should be used. Is that the general gist of the overhang floors?
Yeah, it's It is, we're just trying to prevent any type of sensitive material being at risk of that. So yeah, no super absorptive material should be used, but that's where the allowance for the 2.5 inches comes in. Is we understand that there's a need, especially in a multifamily project, for any type of sound deadening. Like if you've got this as a suspended floor over a garage and you don't want people to have to listen to car noises all the time, you might need a little bit of that air permeable insulation. So that's the key goal there. And also a lot of those absorptive materials, they do, especially cellulose, right? Cellulose in plants is what holds all of the moisture in the plant itself, and it does a great job of it in its new life as insulation, holding moisture content. So it could hold it up against something like a sheathing layer where you've got, where that wasn't at risk of rot, but now that you've got a bunch of cellulose holding onto that moisture content after some kind of bulk water event, that could be a risk. So it's trying to, yeah, it's just trying to mitigate any type of major absorption in there.
And I'll mention too that, you know, so when we're looking at hydrothermal analysis, there's two major modes of failure. It's wood rot and mold growth, right? Those are the two, and they're two separate things, which is important to keep in mind, right? So, you know, wood rot is the sheathing is starting to rot, which is a structural problem. Mold growth is an indoor air quality problem, right? It's mold that you could absorb into your lungs. The other thing I'll note about all of these overhang floors, like, remember, this is prescriptive requirements. If you don't meet them, you need more insulation, you want to try something different, you live in a really dry climate, you can do a hydrothermal analysis. And we have seen, you know, floors pass with more fluffy insulation, more air and vapor permeable insulation than what our prescriptive requirements show. But again, as Al mentioned at the beginning, we're trying to be conservative. We want to make sure that the majority of projects pass without even having to do the extra time and effort to do a hydrothermal analysis. But we have seen, you know, obviously there are floors that have fiberglass insulation in them that don't completely rot out, but we want to be careful about that application on all projects, especially in our projects where it's really airtight. There's not as much ability for that floor assembly to dry out.
Yeah.
Yeah.
And on that too, we only require those to be yeah, cellulose and floor. What I mean, we're all bathroom shower. Yeah. So that is the other thing too, is we, in the way most buildings are laid out, all of the wet and service rooms tend to be closer to the core. And then on the perimeter of the building is where you'll see anything that might have the bump out where that overhanging floor exists. And usually it's not at risk for bolt water events. So in that case, we just follow the prescriptive wall requirements. But it is just those weird situations where you've got a building on a plinth over a garage, and that one floor is over a bunch of fluffy insulation, and that's our concern there.
Yep.
Patricia wants us to go back to the wall detail.
I think this is the one we're on now.
Yeah. Okay.
Yeah, I do want to mention here too that, yeah, sorry, the graphic's a little weird, but in this graphic, the green is both the vapor control layer and the air control layer. Like the legend is like up half a line of text. So that's the vapor control and the air control are both green in this assembly. So I think they're using the same material for that.
Controversy: how to insulate concrete basement walls. Yeah. I think 90% of what we see is typically on the exterior of a wall, where they'll wrap a footer and continue on under the slab. The only time where we see any insulation on the inside is usually a retrofit scenario. And I was just rereading through one of the Building Science Corp articles from
yeah, I'll chime in while you're looking
Yeah.
for that. I'll chime in. So I think the controversies we typically see are when we have a double stud wall connecting to a basement, because in a regular, most constructions that we see now where it's a wood stud wall with continuous insulation on the exterior, typically they'll line up the, you know, the sill plate with the exterior of the concrete wall for the foundation, and then just continue that continuous insulation down the face of the foundation wall. But if you're in a double stud wall scenario where you're doing an exterior load bearing double stud wall, where that exterior stud has to be lined up with your foundation and there's no continuous insulation outboard of it, what do you do in that scenario to keep continuous insulation on your foundation? That's where you'd have to do it on the inside, where I think the inside, that's where the controversy we see happen, because now you suddenly got, continuous insulation and then it meets concrete. And then you have to bring that insulation to the inside, so it kind of jogs backwards. On most of the projects where we see where it's a wood stud with continuous exterior insulation, it's pretty straightforward to just continue that insulation down the face of the foundation wall. Let's see, and then we've got a note in here from Mark. He insulates concrete foundations always on the inside. Continuous is subslab insulation. Concern on the exterior is insects and rodent damage. Ask how I know about this, probably from firsthand experience. That's true. And a lot of projects we see that it's protected with an exterior board, protection board on the outside when it hits the below grade wall assembly, or the below grade assemblies at the basement wall. And Al threw in a link to the building science corp document for avoiding mass failures in retrofits, which is a pretty good document. Protection board just hides insects. Fair. Yes. Yep. Climate is allowing insects from warm climates to migrate farther north. That is true as well. Yeah, we definitely see protection against this in warmer climates for for termites specifically, for the most part, is trying to avoid those. I don't know if we have termites as far north as 5A yet, but someday that could definitely be an issue. Anything else you want to add in here, Al? Otherwise, any other questions in the chat? Carpenter ants, yeah, that's true. Carpenter ants, not just termites. That's true, Mark. Okay, with that, I'm gonna keep going, Al. I think you're good on your end. So now I've got some cost data from actual projects that we've had fully certified. This group, we had to pull data from a couple of older projects. So Village Center, this project in Brewer, Maine. It wasn't in my group of projects anyways, because it was up in climate zone 6A. But this one is also a little bit of an older project. So it's a Fias Plus 2015 project that was certified in 2016. And it was 2.5% incremental cost over what their baseline code proposed building was for this same location, which is pretty incredible in terms of like the insulation that they had to do for this project up in Maine. So it's a pretty good building. It's very interesting. It was Thornton Tomasetti, I think, was the CPHC group who worked on this one. And I think most of these projects that we have cost data for are also available as case studies on the Fias website. So if you wanted to check out the case studies, those are pretty good to look at as well. This project in Vermont, so again, also kind of outside of my scope of what I was looking at in 5A and 4A, was a little over 2% incremental costs. And they noted that the upgrades were in insulation, air sealing, windows, and then cold climate air source heat pumps was the other piece that they counted as an upgrade. I think Vermont has a lot more natural gas systems in it on most of their buildings because, otherwise the alternative is electric resistance, because it gets really cold, and a regular air source heat pump that kind of cuts out at 10 degrees or so. In Vermont, that's a big deal. Like, that's not a great thing to happen. So the cold climate air source heat pumps were an upgrade for them. And this one had hydronic heating and cooling only air source heat pumps. So this was kind of an interesting combo of things going on. And yeah, their site EUI came out at about half of what their baseline was run for this model, which is pretty good. And their baseline included ERVs in it as well. So not just, it's not just all in the ventilation or anything like that. Let's see. Pennsylvania has quite a bit of cost data available now. They started their program a little bit earlier as well. They have their first funding opportunities available. So with experience, the passive projects are costing a lot less than even the regular projects that are not passive. So it's not necessarily about increased cost anymore with those projects in Pennsylvania. It's looking at where are you putting your money, where are you investing. So it's kind of trading from, maybe interior finishes, I think, is something I hear anecdotally a lot of, like, okay, we don't have like granite countertops, but we've got an ERV and we've got, triple pane windows, and people are more comfortable. So that's kind of interesting cost data information as well. Again, a little bit older, 2015, 2016, and 2018 data we've got to look at here, which is kind of cool to see that the cost premium is coming down for passive projects as those folks are getting more experienced in building them, which is really, really good to see. And 2017 isn't included here because they didn't have low-income housing tax credits through PHFA in 2017. So they kind of skipped that year in terms of this graphic. Massachusetts, I probably don't need to spend a lot of time on this slide because you guys hopefully are familiar with this and have seen this data. But again, between 1 to 5% cost increase on a number of projects that Fias is working through for Mass's CEC. So again, all these pretty decent sized multifamily projects. We have plenty of data on multifamily because that's what gets the most incentives in a lot of these different regions. And it's the stuff that gets the most attention because cost is really a big deal for these, low income housing agencies. We don't have quite as much data on single family. And I always kind of have, it's kind of sad for me. Like I like single family projects a lot. I think the idea of, each person taking control of their own home and like trying to reduce their energy is really, really heroic. It's really great. The other thing that we see with single family homes though, is that they're usually custom and it's usually the fancy houses that we see, right? So when you're trying to look at cost comparisons, it's like, okay, this costs a lot more than market rate, but it's also got the fanciest stuff on the inside of this house you'll ever see, right? We've got our own sauna. We've got there's plenty of other stuff that goes into these homes. It's not just passive building measures in terms of the cost. So it's kind of tricky. You'd have to look at it way more granularity for a single family home if you're trying to parse out, okay, how much more did we actually spend because we're trying to save energy, and how much did we spend because we're trying to make the nicest, best, fanciest house we possibly can for ourselves. So it's kind of a weird dynamic we see in our field with passive buildings, where we have a lot of affordable multifamily projects and a lot of custom single family homes. And the reason is because both of those groups are going to pay for the energy use of that house for the next 50 years, or that project for the next 50 years. So where they don't overlap in terms of, like probably in most other groups of things that, it's a really wealthy individual who's building their own custom single family home versus an affordable housing developer trying to cut costs as much as possible. Again, where they overlap is they're going to be spending for the energy of the building for a very long time, and they're trying to reduce that. So yeah, commonly reported increases in costs, improved ventilation. So this is mechanical ventilation systems. A lot of projects in a lot of the areas of the US would not even include a mechanical ventilation system. So that's an automatic increase in cost. Air sealing is one that we get a lot of pushback, especially in the warmer climates. They just don't really see the benefit, and they get charged a lot more to improve the air sealing in the buildings. So particularly in Texas, not to really draw, not to call Texas out, but we have heard anecdotally from builders in that region, and more often from the architects talking about the builders, where the builders say, why? Like, this is way too hard to do. Like, this is impossible. We're going to have to charge you 10, 15 times what we would normally charge for air sealing, where in the colder climates, it's kind of makes sense. You want to air seal and it's not as big of an issue, but air sealing is a cost increase we've seen. Window upgrades, a pretty obvious one. Better windows cost a lot more money. And then installing them and shipping them also is, to get the windows that we need, which are air sealed and, performing well. It's a big cost upgrade from a typical double hung that would normally have gone into an affordable housing project, right? To switch it to a casement or, really good fixed pane windows, et cetera. Thermally broken cladding attachments we've seen as a cost increase as we've seen more and more continuous insulation on the exterior of wall assemblies. So if you're basically the cutoff point is typically when we see more than 3 to 4 inches of continuous insulation outboard of the wall, that's when the cladding attachments really start to get expensive, because when you're doing a double or a wood frame stud wall, you're trying to hit a 1.5 inch wide stud with a fastener that's between 5 to 6 to 7 inches long. That gets really difficult to do, and people miss a lot. So trying to reduce how much exterior insulation you have, or improving that exterior insulation and keeping it to a more manageable thickness, is something we've seen project teams start to do more often. So trying to look at doing kind of these zip R sheathing systems where the exterior insulation is only 2.5 inches thick or something like that, and then making up for that reduced wall R value in other areas. So more roof insulation, a little bit better windows, stuff like that can be used to offset kind of these cost increases we've seen. We're trying to do thermally broken cladding attachments. And then the last part, which I don't know how much more cost this has in comparison to how beneficial it is. Like, I don't know if people really think about this too much, but additional on-site construction verification, or the quality assurance stuff that happens from our raters and verifiers on site, is another cost increase that project teams like to point to as we don't want to pay for that, but that is the one thing in my mind that's ensuring the owner gets what they paid for in the first place. So we've seen this time and time again where the on-site quality assurance has, in my opinion, would have paid for itself by finding errors on site and correcting them before the project is completed, and then you'd have to rip a bunch of stuff out and retrofit it. Which, like, if we take that into account, I feel like this is more than worth it. For every building should just have this, because we constantly see this as an issue. But that on-site quality assurance, I think, is incredibly valuable. And while it is an increase in cost, it's well worth it, in my opinion. A couple more projects to point to specifically. So here we go. Finally, one in Massachusetts for you guys. This is the Finch Cambridge project. Again, a little bit older of a building. I think this one was certified back in 2017. So it's a little bit older of a project, but again, 1.4% incremental cost for the whole building as a whole. And it came down to the ventilation, the soft costs, enclosure upgrades for the insulation and the doors specifically, and the windows, air sealing, and then they included sunshades on this project, which is not typical, but a pretty nice feature for a change in climate and trying to improve the shading capabilities of the building when it's in a cold climate, but it's a densely populated building. It's going to have a lot of, especially with the climate changing, it's going to have potential overheating issues, and the sunshades were a strategy for them to try and reduce that potential in the future. This is a project located in Al and my backyard in Chicago. It's called TR Linda. It's an affordable housing project that's a 6-flat building. So it's multifamily, but relatively small. And this was a really cool project, and I encourage you guys to look online on Fias's website for this study as well. So this affordable housing developer built 2 projects. They did an Energy Star project and a Fias project. Basically, they did the Fias project first, and then they did the Energy Star project after the fact. But they are, by all intents and purposes, identical buildings. The Energy Star project just didn't have the same windows, the same ventilation system, and a couple of other wall sealing, air sealing stuff. Those were differences. And so basically the Fias project had lowered the heating load by about 65% from the Energy Star project. But the incremental cost was almost negligible. They basically cost the same amount of money. It was just what the project team spent money on. And overall annual energy costs were about 20% lower. And this is kind of fuel switching was a majority of the reason. And again, this cost data is from about, I think 3 or 4 years ago at this point. Like, COVID kind of put a little bit of a downswing in terms of us getting actual cost data for a lot of these projects in terms of the annual energy costs. But the Energy Star project had all natural gas systems, so natural gas furnace, gas dryers, et cetera, and a gas stove. And the Fias project had air source heat pumps, et cetera. So switching, the fuel switching is a big factor in why the annual energy costs aren't as significant as I think they might be if we looked at the cost right now. Now that we know the cost of natural gas and fuels and stuff like that are slowly going up. Electricity costs are also going up with inflation in general. But I think if this project was looking at just from a pure energy savings perspective, this is pretty successful story. The other thing that I'll bring up that also goes into the annual energy costs is that we also included the cost of having the hookups for those energy sources. So the electrical panel hookup and the natural gas panel natural gas hookup are both included in the monthly costs for both of these projects. And I only bring this up because, like, as the reviewer going through this project and watching a project go through my backyard, and I was really happy about it when it came on and was finally like, yeah, we get a multifamily project in Chicago. The one downside of this project is that basically the tenants they had planned, or the developer, basically they only do natural gas stoves. That's all they do. So even though the Fias project has a air source heat pump for the heating and cooling system, and it has a, basically could be all electric, they kept natural gas for the stove. So they still have a $35 monthly payment per unit just for the natural gas hookup for cooking, which is kind of I don't know, like, that to me, like, they're using like literally, I think, about $3 worth of gas for cooking, but they're spending $38 a month. And if they were going to do it again, this affordable housing developer was like, oh, we would have made it all electric for sure. Like, it's just an unnecessary $35 a month, which they have to charge their tenants just for cooking with a gas stove. Oh yeah, this project, when it was going under design, was getting designed in 2014, 2015, before we had all of these really nice resources to point people to about indoor air quality concerns with gas stoves, et cetera. Again, if they were to do it again, they would have easily just done an induction range and a cooktop. Like, it would have been so much easier, I think, for them to make that decision. So yeah, so cost data and justification, this is always a good conversation. People want to look at final numbers, make a decision on that. But when you're looking at incremental cost, you have to define a lot of things. You have to define what the baseline is. Like, is this just a code study as she goes building? Is this a little bit better building? Like, what is the baseline? The client's priorities are also very important in terms of cost and justification for things. A lot of the affordable projects we're seeing where the client's priority is to, number one, get the incentive money to do the project in the first place. That's a big push towards going forward and trying to hit these energy targets, because Fias is written into a lot of requests for proposals, a lot of RFQs, et cetera. So, and then the last part is that the team's first project. That's another big thing that is accounted for an incremental cost. So if the project team is just doing this for the first time, there's a lot of cost associated with the learning curve of getting through your first project. And as was evidenced by the PHFA's data earlier, like the 2018 projects are actually less expensive than their code comparison basis. It's because those project teams are more experienced now that they've seen these projects come through. One other thing that's not in here either, I think, is the availability of materials, like especially windows. We're seeing more and more available window manufacturers. Again, that big long list of windows I had, if we'd looked at this 10 years ago, that list probably would have been like maybe 5 or 6 manufacturers that could reliably produce the windows that we're kind of looking for these projects. So that, I think, has helped with the decreased costs over the years as well. And then, yeah, is simple payback method all we care about, or is it money spent now in the present? Is money saved in the future? Because you're looking at how much you're spending on bills over the next, lifespan of the building. And then, yeah, this is another conversation piece. It's not necessarily directly related to costs, but it's something that we like to talk about in terms of, what other things besides cost should we be talking about when we're looking at these buildings? And it's about comfort, indoor air quality, the long-term durability of the buildings, and then the resilience as well. As evidenced by the past couple outages we've seen in a couple different areas. Texas in particular had a pretty notable outage last year. And we had 2 projects that were certified in the Austin area. And I recommend you guys check out, I think Trey Farmer is the architect of one of those 2 projects. And his home was one of them, and he was actually able to stay in it for 3 days with no power during all of Austin's outage situation. And he was telling us anecdotally, like, his neighbor, and his was a retrofit project, which is even more interesting. So his neighbor has an almost identical unretrofitted house, and within 8 hours, their house got below 32 degrees Fahrenheit. And Trey was saying that his house never got below 58 or 60 degrees, which is arguably cold. But when your neighbor had to evacuate after 6 hours because it got unbearable, it's kind of a big deal. So again, all of these are really interesting things that we need to continue talking about and pushing forward as other things to discuss in terms of, okay, it costs 2% more, but look how much you're getting better for comfort, indoor air quality, durability, and resilience, et cetera. And Hank has a question. Go for it, Hank.
Yeah, so I would add to this list the impact on the grid itself. The idea that we're moving toward all electrification, forget these people who are still doing gas hookups for their stove. We're moving to electrification. And if we don't do that in conjunction with passive house metrics, we're going to put a huge impact on the grid going forward. And that should be part of this. What else should we be looking at?
For sure. It's a very good point. And I think Al and I can bring that in the conversation when we look at the mechanical systems on Thursday. I'll make sure I talk with Lisa and get some slides from her about her grid interactive building slides, and basically looking at, exactly what Hank's talking about. If tomorrow we switched all buildings over to electric buildings, all of a sudden our grid wouldn't be able to support that. We need to try and reduce some energy use first before we move in that direction, which is why this is kind of they work together really closely. Let's see. I think I've got a couple more slides. These are just kind of fun ones. This one is a cycle that we've seen very consistently over the past few years, that the more projects we see constructed and the more cost data and measured performance we get, the more the policies and the incentives catch up, and then that further fuels more projects, et cetera. So it's been a really good thing for us to see, and I'm very pleased with how the incentives and the policies and how people are having this conversation that know very little about like the building industry in general. They're just trying to do good by the environment, and this is a big step in the direction to help with that. So this is just a good graphic, and please feel free to look at the Fias website on the current policies and incentives that we're currently tracking that are all kind of, we're in a lot of the stuff going forward, which is really good to see. And then last slide I've got, and then I think we can open up for a few more questions. I know we're a little early, but shameless plug for FiasCon, which is coming up in Chicago. So I know you guys are in the Northeast, but please feel free to travel. It's coming up very soon, less than a month out. Pre-conference starts October 25th through the 26th. And then the main conference is the 27th through the 28th. So if you don't have any fantastic plans for Halloween, please come and join us, and we'll talk in person. This is a great question. I think CPHC credits should be available. Did we get a slide, Al, from Jenny on that, or do we need to send that to Aaron?
I will follow up with Jenny and get that to Aaron. Yeah, this should definitely be worth 2 CEUs. James did such a good job, so maybe 3.
And then the last part, mechanical systems is coming up this Thursday. So hope to see you guys all again on Thursday. Otherwise, open the floor for any other questions we have on like cost stuff. It's interesting, and the more we get, the better it is.
James, Al, thank you so much. This was a lot of really, really great information. A lot of it, we're seeing for the first time, and I know you put together a lot of it for the first time. So it's great to kind of see this all presented in this way. Obviously, we will open the floor to questions that folks have. I do see one hand, I think, raised right now. That's Hank, unless that was from earlier.
No, that's me now.
Okay. Go ahead.
Okay, go back a slide. So Fias policies and incentives. As you know, Massachusetts has had a great incentive for Passive House for the last 3 years. We've gone from effectively 0 to 8,500 units on the boards and into construction. We're about to see that ratcheted up because our stretch code, our opt-in stretch code, will be going into effect at the end of the year, and that will require that all multifamily buildings over 12,000 square feet be Passive House. So the combined effect of all of these things is going to be a further explosion of Passive House, certainly in Massachusetts. And I think I want Fias and Fee to think about how they're going to service that demand, because the good news is this legislation calls for certification. We don't want this to be, yeah, we're kind of designing maybe to Passive House. We're asking for certification in these codes. And that means we have to depend upon you to be able to do it. So you don't need to answer me now, but that's an issue on the horizon, ramping up to meet the demand for certification services.
Yeah, it's a very good point. And I want to touch on two parts of it. So I'll answer your original question second. The first part I want to point out that I very much appreciate is the requirement for certification. And just for those of you who don't necessarily know, when Pennsylvania, who was one of the first groups to do these incentives for their request for proposals for their low affordable, and they gave incentive points for Fias projects, they originally just required pre-certification or design certification for their stuff. And we saw a ton of projects go through the process and then opt out of the quality assurance on-site stuff because they just required the design certification. So I really appreciate that Massachusetts is going forward with requiring full certification, because the on-site quality assurance is, again, as I say, invaluable. Like, it's a very, very important part of the whole puzzle. And then in terms of what Fias is trying to do to ramp up for this, we're aware of a lot of policies going through. It's very exciting. And just to give you guys a little bit of an inside view of what Fias has been doing. So when I got hired in 2015, I was one of 3 reviewers for certification staff for projects. So Lisa White was who's now associate director at Fias, was our certification manager. She had my job. I was hired straight out of college and started doing reviews. And then our senior scientist, Graham Wright, at the time was also doing a few project reviews, not very many. But since then, our certification staff has grown up to 8 people. So I'm the certification manager now, and I oversee 8 folks who are doing reviews. And then we also have 2 interns, which I'm hoping to hire both of them in the coming semester when they both graduate. So hopefully we'll bring our total reviewers up to 10, which would be incredibly helpful. And basically our goal is that we keep basically each of us is a little bit of a Renaissance person, where we're doing reviews all the way through from start to finish and know enough information about every piece of the process to get projects reviewed in a very timely manner. And we do our darndest to hit our review dates when we have them set. So that's part of our growth, is trying to get more and more certification staff on board and get more projects reviewed and back to project teams so they can continue their design. The other piece that we're really trying to work hard on is to get more raters and verifiers trained. That's a new push we're looking for 2023. We have quite a few locations, not just in Massachusetts, but kind of throughout the US, where professionals are few and far between, and we see a need in a lot of regions for more raters and verifiers to be able to finish these projects out. So that's a push. And then I think in general, a lot of the stuff that happened with COVID of a lot of folks having to move to virtual trainings was a really positive thing for Fias. We've had consistently filled builder trainings for the past 3 years of every single month having builders getting trained, which is really, really good, I think, for looking forward to the future. And so I think those pieces together we're gonna have to keep working on each of those to help meet the demand that, yeah, Massachusetts is really leading the way on. I've heard anecdotally from a couple different groups, we could look at anywhere between 50 to 400 projects in the next 2 to 3 years. So those things we really need to have our finger on the pulse for, and we're working to try and increase our capacity to help meet those things.
I'd like to do one follow-up to that, and that's pointing out what we did a few years ago when we built Passive House as a pre-approved alternative pathway for energy analysis. We also built into the new stretch codes, and that is that we require pre-certification attested to by the CPHC, and the fact that the project has been built to those standards and can meet the certification standard. That's what's required for a building permit. And then not a building, but it's a permit at the front end and an occupancy permit at the back end. Because the idea that you might have to wait for certification to come through before you can get an occupancy permit would be the kiss of death specifically for affordable housing developers. The missing that deadline can cost them tremendous amounts of tax credit losses. So we built the system that way very specifically, and it puts a lot of responsibility and emphasis on the CPHC, but it's a critical piece of language in the way you set up that code compliance to avoid real problems.
No, that's really good and interesting to hear. And I hope we have more states develop similar language to what Massachusetts has. And I hope it'll prove to be really, really good system. But yeah, that's good points, Hank. Thank you.
I don't see any other questions at the moment, James, but I actually want to ask one of my own. You were talking about Finch Cambridge earlier, and you mentioned the shading systems that they have, and that those are uncommon. And I talk a lot about, when I give presentations, the importance of optimized solar heat gain and avoiding overheating. So I'm just kind of curious, for my own benefit, what kind of systems do you see as common for avoiding overheating?
Yeah, I think the top 3 are overhangs. We do see them not very, very frequently, but we definitely do see them, especially on south facades. They're not nearly as effective on west and east facades. So if the building's just oriented that direction because that's the plot that the project is given, we don't typically see them on east and west orientations, but we do see them on the south facades occasionally. More often than not, we will see just lower solar heat gain windows on multifamily affordable projects than we would typically see on a single family in the same region. Usually project teams are kind of fighting to meet the cooling targets when the projects are much more densely populated. So that kind of incentivizes them to use the lower solar heat gain windows in general, which is hopefully preventing some overheating. And then just regular interior blinds is a big one that a lot of project teams rely on to try and, it's not going to prevent the solar, the heating from getting into the building, but it delays it. And that can be an effective way to help reduce the immediate cooling demand when people are in their homes. So we see a lot of interior blinds more than we see exterior blinds, because they just have a lot more issues in terms of long-term durability, especially on affordable housing projects. Go ahead, Hank.
Yeah, I would just add that in my passive house, what I did is I took on the critical south facades, I took and put 50% and 2/3 of the windows in the various spaces with a 4th pane of glass and the Venetian blind on the outside of the triple glazing. And I studied all kinds of overhangs and retractable this, and it was all getting crazy. This is an extremely simple solution that knocks out the heat gain before it gets through the triple glazing. And I think it's something that people need to be aware of and think about. It's available in these windows now, and it's really effective.
That's a good point, Hank. And yeah, we have seen that on quite a few projects as well. Again, mostly on single family. It's a little bit tough, I think, when if you're trying to keep down, and this is kind of an interesting problem that larger multifamily projects have, that until we started seeing them, I wasn't really thinking about too much. But, if you've got good double pane windows in a multifamily, and then you add a third pane for your shading device, you've increased the weight of your window by a third, which is sometimes a big deal structurally for some of these projects, which is why we've seen more and more projects use really good triple panes with low soil heat gain as a kind of a compromise to what Hank is proposing. But yeah, for sure, I've seen those on projects as well, Hank, and I agree. I think it's an elegant solution, and it protects the blind. It stops it from getting bugs and stuff inside of it and getting all messed up. So yeah, I've seen those too.
Great. Well, thank you so much. And I don't see any other new questions, and we're about at time anyway. So it's a good point to end. James, Al, again, thank you so much for putting this all together. And we will see you again on Thursday as we move this conversation into mechanical systems.
Thank you. Great job.
Take care.
Thank you all. Thanks, everybody.